All right, hi there. This is going to be a lesson on graphing square roots. As you can see up here, the formula that I've written down is the driving formula that we'll be using today. Y equals a times the nth root of x minus h under the radical, and then plus k on the outside. And these letters, a is greater than 1 will represent a stretch. If a is less than 1, between 0 and 1, it'll be a shrink. Excuse me, if A is negative, it'll be a reflection. And H will be the horizontal translation, and K will be the vertical translation. You're welcome to write this down. You should know it, be familiar with it. I'm not planning on giving it to you in front on the test that we have later on, but you could be familiar with it. It's really the same type of thing that we've been doing with all these other translations. So let me show you what I'm talking about with that. I'm going to go to my online graphing program, the Desmos, bettergraphingcalculator.com. So if I was to do the parent function, which is like the original, most basic one, y equals the square root of x, I get that. All right, there's no negative values. It's only in the first quadrant because it's all positive numbers. The domain is x is greater than or equal to 0, and the range is y is greater than or equal to 0 because you only get positive numbers. So that's the original one. Now if I was to take that same equation and go y equals the square root of x and add a plus 2 on the outside of the equation, what you probably would expect to happen does, where that's the vertical translation of 2 units. You can see it's the exact same graph, just move 2 units up. If I was to do the same equation, except I was to go minus 3 at the end instead of plus 2, you can see it's a vertical translation of 3 units down. All right? So that's how we start. And then if I was to change this around, supposing keeping it under the radical, instead of having minus 3 under the radical, outside the radical, if I put it under the radical, you can see that it's now became a horizontal translation, 3 units to the right. As usual, if it's underneath the radical with the x, and it could be in parentheses or not, as long as it's under the radical, like you can see over on the left, that is going to be the opposite direction of what you think. It moves 3 units in the positive direction. Even though it's minus 3 over here, you'd expect it to go 3 units to the left, but the horizontal translation is opposite of what you'd think, just like with all the other translations we've done this year. The vertical one is exactly the way you'd think it was. Plus 2 moves it up 2, minus 3 outside of the radical moves it down if it's negative. All right? So that's the basics with it. Now, if I was to take it one level up and and put a number in front of it, it's either a stretch or a compression. So supposing I took this one here, and actually I'll do it with this one. Delete that one for a moment so you don't have to see that. And if I went up here and say I put a 6 in front of there, well, it just became a whole lot steeper. All right. So that's a stretch. 6 is kind of big. Maybe I should make that smaller, make it like a 3. And you can see now that you can see more of a stretch that way. Okay. Now if I was to change the 3 to a 0.5 and made it between 0 and 1, you can see now that it would be a compression. It's pushed down on the graph. Okay. So that's what happens when you mess with A, change A around. Now if I was to take it and make it negative, if I had a 0.5 and made it negative 0.5, it's a reflection. In fact, you end up with a parabola if you put the two together. And it's the exact same thing, it's just that it's on the negative side. Okay? All right, so that takes care of the A portion of it. Now, they may not all be square roots, right? And I want to show you a couple that aren't square roots. I'm just going to stick to third powers here. Now, this program kind of limits me because it won't let me do third roots. So what I'm going to do is, I've shown you guys before that if I take something to the 1/3 power, that's the same as the third root. So that's what I'm going to do with this program, since it doesn't have the third root button on it. So that's what a x to the 1/3 looks like. Okay, so if I was to take, that would be the parent function. If I took y equals x plus 2 inside the parentheses, and then take it to the 1/3 power, you can see it took that curve and it just moved it 2 units to the left. Okay, if it was plus 2. If I change that plus 2 to a minus 2, it moves it 2 units to the right. You can see the blue one went from the left to the right. Now I could take that and go minus 4 at the end, put it outside the parentheses, and it moves it down 4 units. You can see it's the same kind of thing, except it's got a horizontal translation of 2 and a vertical translation of 4. Now I could do the same kind of thing. In fact, it would be an inverse function if we were to use some of the terminology that we used in class already. And this time, instead of doing a third root one, if I did an exponent of 3, that's what y equals x to the third looks like. And if I took the same kind of function, and I went x plus 1 in parentheses to the third power, you can see it just moved it 1 to the left. Okay. If I put a minus 2 outside of it, well, now it moved it 2 units down and 1 to the left. So I usually look at where that center point is of the curve there. And that would be the inverse of the 1/3. Since, and we'll get more into that in class about how to go algebraically from the inverses. Okay, so that's the root ones. It's more important the third root than the third power, but we did the third power ones earlier in class. So that's how you graph those. Now I know most of you have graphing calculators, which are great, you know, and they can help you a lot with these kind of problems. If I was to take just a quick one of y equals negative x, the negative square root of x being the parent function, and y equals negative square root of x plus 1, and I asked you, you know, what happened with the translation compared to the parent function, I would hope that you could describe it to me. So let me graph the two and then I'll describe them to you. Y equals negative square root of x plus 1 being inside the radical. Okay, so there's two things that happened. First one was it's a horizontal shift 1 to the left. And the second thing that happened is it's a reflection because A is negative. All right, so those would be the two things that happened. So those are some of the types of problems that you'll see up on your next test. I might have you graph it. I could even say if I gave you, suppose I took the negative sign out just to clean it up a little bit. If I asked you to take this function y equals the square root of x plus 1 and find the inverse of it, and if I did that quickly, you get, you know, y equals x squared minus 1. You know, this would be the inverse, although this one's got the plus and minus. So if I was to do this one and have both of it, you know, you would see that it's it would be the inverse of it. All right, so anyway, we can do more of that practice type of stuff in class tomorrow. And I gave you the equation. I'll put it back up here for you if you want. So this is the driving equation for today's lesson. Thanks for watching, and I'll see you all tomorrow.